Welcome to BotBros. Today is day 6 of our challenge where we'll be mastering DSA for AI in Python. Without wasting any time, let's begin what we learned today in this lecture. So we'll understand why DSA is essential for AI, work with list, tuple, dictionary and set efficiently, implement searching and sorting algorithm, optimizing AI performance using right DSA choices. So coming to part 1, why DSA matters for AI. AI model possesses massive amount of data. Choosing the right data structure saves time and memory, making AI solution faster and scalable. So neural network uses graphs and matrices. AI agents store memory using dictionaries and lists. Recommendation systems like the YouTube recommendation algorithm search efficiently using hash tables. So now let's understand what is list, the AI workhorse. Lists are ordered, mutable, and widely used for AI storages. So let me show you a list basic how it works and how can we code it. So let me create a new Python file. I will name it as day 6. Rename it. And here we'll understand what exactly is list. So list contains a set of data in a structured format of the particular data type. For example, now in data, I can give values 2, 4, 6, 8, and 10. And if I print data of 0, then you will see that in the list, the first element will be considered as 0 and the following will be considered as 1, 2, 3, and etc. So begin with 0 and end with n minus 1. So now if I run this, you'll get 2. Now let's give another statement to append. Append does just add the data into the last place. So if we run this, you'll understand what exactly happens. So now it says an error. So what do you think the error is? The error is we haven't given data.append. So once you give data.append, append will work, and now you can see that print data.append none. So this just appends the data without printing any value. So now if we run this, it'll just show 2. Once the data has appended, what we'll do is just print data. And this, once we run, we'll get the appended value as well, 2, 4, 6, 8, 10, and 12, which has been appended here. So now if we have to check what is the length of the data, we'll just add len, that is a keyword for length. And this we run, we'll get 6. So here you can see that only 5 elements are present, but due to append, the 6th element will also be added to the list. So this is basic of list. Now, as we have covered list, now we'll understand what is list comprehension, fastest way to create a list. So if you have to store the squares of each number starting from 0 to n, then what will you do? First, you'll take the value and then put a for loop, and then inside for loop, you'll do x into x. Instead of doing all those stuff, what we'll do in list comprehension is we will just put a single line of comment stating x square is nothing but x, and double star means that it is the power of 2 for x in the range of anything. Let's give us 5 as the range that we want to store for. Now if we print sqr, then you can see that values starting from 0 will be given as the square. So 0 square is 0, 1 square is 1, 2 square is 4, 3 square is 9, and 4 square is 16. So here you can see that in single line we have done the whole code. So this is called list comprehension. Now, as we have finished the list, let's go and understand the next topic, that is tuples. Tuples are secure and fast. Tuple are immutable list. Immutable means that they can't be changed. So now let's write a small sample code for tuple stating let's give some coordinates as the value equal to 10.0 and 20.0. So now if we print or denames, then what you can see is the value this has will be printed. Now remember, tuples can't be changed during the program, where list can be easily changed during the program. So this covers even the tuples. Tuples are used for storing AI model configurations, as these are faster than the lists. Okay, now let's go to part 4, that is dictionary. AI memory bank. Dictionary is one of the most important parts of an AI, because in dictionary we store key value pair and used in chatbots, AI agents, and NLP. So knowing and understanding dictionary is very important, as this will come in many places. So now to initiate or give the values to a dictionary, what we'll do is just put AI response equal to, and then for dictionary you'll open the curly braces and say hello is the word that will store the value. Hey, how are you, question mark. So now when I call hello, this has to store the value hey, how are you. And if I have to store multiple values, then just put comma and say Python, and this will say the easiest language to learn. So now what we have done is we have initiated a dictionary, or we have given values to a dictionary. Now how to call the value? Just say print AI response and say let's give the value as hello. For this, remember, you have to open the square brackets and just say hello. Now, as this is in print and we have given hello, you might think that we'll print the value hello. But as AI response is a dictionary, so the value associated with hello, that is, hey, how are you, has to be printed in this. So now if I run this, you can see, hey, how are you is printed. In place of hello, if I remove and just put Python and rerun this, it'll say Python has the value easiest language to learn. So that value will be printed. So always remember, in dictionary, it is very important to understand the key value pair that is present. I'll just rename it as dictionary. Okay. Now let's go to the next topic that we have. That is set. A super fast lookup. So sets store unique elements and are used in data cleaning and AI filtering. Unique values is 1, 2, 3, 3, 4, and print unique values should give us the output 1, 2, 3, 4. So now just to understand what exactly sets is, we will just write the same sample code that you just saw and say sample equal to curly braces 1, 2, 3, 3, 4, 5, 6, 6. So now if we print sample, this will give us the unique values of 1, 2, 3, 4, 5. This here will help us in data cleaning of huge multiple data sets that will be available for the AI model training. So now coming to part 6, this will be an interesting and a challenging part to learn, as you have to know the basics of searching algorithm. Searching is a key element for AI application for recommendation systems and pathfinding. So what exactly we do in searching is we'll have a list of elements and we'll be given a key element that we have to find in that list. So we majorly have linear search and binary search. So if you want to see an example, let me just show you. We'll have indices like this and say an element 6 has to be found. In linear search, it goes one after the other until it finds the element and sends back the data. So now let's directly jump into the code of linear search. Linear search. So I would just say def ls. The values that we'll be passing is nothing but the data and the target. Target is the element that we have to find from the data set. So for I, comma, value in enumerate of the data, and say if value equal to target, then what you do is return the value, or maybe the I index, because we might need which position it is presented, and if not, return -1. So now here let's just call the function or the class just by putting print ls of the data set can be 10, 20, 30, and 40. And the finding element, let us keep it as 30. So we will find the index of this 30 if it is present in this row. So now if we just run this, it'll say an incomplete input error. So what exactly had happened was I missed braces. Now if I run this, it'll say 2. So here you can see 0, 1, 2. This is absolutely right, because the way this runs is it'll send the whole data set into data and the value in target. For I will be the index. Value will hold enumerate of data. Enumerate means separating each data set into a different set and calling each one after the other in the for loop. And once if the value is equal to target, we'll return the index. So now if I just remove 30 and give it as 400, as the data is not present, it will return as -1, stating the data is not found. Similarly, in binary search, what we do is we say def binary search data and the target. It will be the same. The only thing that changes is from here, we'll give L equal to 0 and R equal to length of data minus 1. So now why did we give this? So if we just check how a binary search works is, first if you have an element that has to be in a sorted format, and we'll have a target value. In linear search, it went like this, but in binary search, what it'll do, it'll go to the middle element and check whether that element has 6 or not. If it has, it'll return the index. If not, then what it'll do is it'll check whether the target value is in the right side or the left side by just checking whether the value is higher or lower. And once it gets to know if it is higher or lower, it'll go there and divide the whole. Let's take 3 as an example. The 3 will not be found in the mid. So it will come here, it will divide 1, 2, 3, 4, 5, 6, and then find the middle element, that is 3. So 3 is found here, and then it will return the value of 3. So if I have to show you how the code works, it is very simple. While L is lesser than or equal to R, and then say mid is equal to L plus R. Let me put that in braces, divided by 2. For divided by, remember you have to put double divided by symbol just to ensure that it is a division in Python. If data of mid is equal to target, return mid. If data of mid is lesser than target, then what we do is, now as the data is lesser than, we'll pull the left is equal to mid plus 1, else right is equal to mid minus 1. So now if none of the data is found, inside the definition we'll just put return -1. So now let's call this function by just saying print. Let's copy the same thing and then paste it here. Just remove this. Say print. It's binary search and let's keep it as 40. So now this will give us the value that is 3. So this is the binary search where you have 10, 20, 30, 40, 50 and then you search for the data 40 from this set. So this actually helps us because the time taken for it to complete the whole task will be O of log n. That is much faster than our linear search that is O of n. Now let's jump on to sorting algorithm. So sorting algorithm, you have two primary sorts that is bubble sort and quick sort. So what the sorting algorithm exactly do is ensure the array whichever random format you have given into a proper formatted structure or in a sorted manner. So now let's take bubble sort, which is a basic sorting technique. Now it's bubble sort. So in bubble sort, what I'll do is define bubble sort, which will send out array value. Here we don't need any target because we have to just sort the array and of array, and then for I in a range of n, and then for j in a range of n minus I minus 1 if array of j is greater than array of j plus 1, then what we'll do is just simply swap these both. So to swap, the variables can be given on the left side and then equal to on the right side. Array of j comma array of j plus 1 is equal to array of j plus 1 comma array of j. So now this will give us the sorted format, and then finally what we have to do is ensure we just return array and then call the function. What we'll do is just say print bsort and say give the values for the array as something in any random order like 5 3 1 8 4 7 9 or 0. Okay, so this will be a random sorting format for the bubble sort. Now if I run this, it will give me the unique values present in this, or maybe 0 2 3 4 5 7 8. So now if I just add another value, what do you think will happen? Will it give us the unique values or will it give all the values? That's a trick question for you. So now if I run this, it will not give unique values, but instead just order the format and give us the sorted format. So in bubble sort, what exactly happens in these two for loop is very important. You have to remember that in bubble sort, the high weighted element will go to the rightmost and the small weighted element will come to the leftmost. So in this array, by the time this array runs, you will find the sorted array given. So now if we go to the next sorting algorithm, that is quicksort. So quicksort is very simple. It is same like the bubble sort, but it is much faster. So what exactly we do in quicksort is we'll have the array, we'll break it into left, right, and mid. So the mid element will be constant and we will change, we'll keep all the higher elements to the right side and the smaller elements to the left side. And then based on that, we will do all the changes that is needed. So let me quickly write the quicksort algorithm for you. Qsort, and then if let's just pass array and say if length of array is lesser than or equal to 1, then what you do is just return array. This is a very important step because you'll understand why exactly we have given that. Pivot is equal to array of length of array by 2. And once we have got this, next what we'll do is L equal to x for x in array if x is lesser than pivot. Okay, and then mid is equal to the same value x for x in array if x is not lesser than but equal to pivot. And then for right it is also the same x for x in array if x is greater than pivot. So here what we exactly do is we search x for all the values present, we find the mid from pivot, and then from the values found we'll find what all the values will come to the left and what all the values will come to the right. So now what we have to do is just return q sort of L plus mid plus q sort of R. And then here we'll use the same function that we had used. Then instead of B, we just put Q for quick sort. So now if I run this, you can see that length of array is a problem because the braces didn't match the correct ones. No. Now if I rerun this, it'll say L equal to X for X in array of X. Invalid syntax. It was a silly error that was backslash. So now if I rerun this, you will see the sorted algorithm. So here you can see the quick sort is much faster than the binaries bubble sort. The reason being bubble sort has the value of on square, that is the time it takes for this to run, that is 2 for loops, and here it is way faster and it takes just n log n time. So now let's come to the challenge of the day. So what the challenge is: to build a simple chatbot that uses dictionary for storing responses, searches for user inputs using searching any algorithm, and then returns a sorted list of most relevant responses. So this is a very important and a challenging one for any of us. So let's do the challenge and meet you on the next day. Thank you.